Alright guys, welcome back. We're going to finish up the day 3 notes. Alright, so we're picking up on example 3. We're talking about the average rate of change. We're looking at the exponential function. We're going to look from where x is 0 to where x is 2. So remember, these are the x values. We're going to find the y's that go with them. So when x is 0, we've got this point here. And when x is 2, we've got this point here. So let's just go and figure out what this y value is so we know. Okay, if I put a 2 in place of this, so you might need to use your calculator to help you. I'm going to do it by hand. So if I square this, that's going to give me a 1/4. 2 times 1/4 is 1/2. So that y value right there is 1/2. Sorry, you can't see that on the bottom of my paper. There you go, a little bit better. Okay, so now what we're going to do is we're going to say this is down 1 and 1/2 and over 2. So we're going down 1 and 1/2, which I'll just call 3/2. Okay, or you can call it 1.5 if you want. You can do that for, if you're using a calculator, 1.5 might work a little bit nicer. I'm not using calculators here, so 1.5. And then we're going to go over 2. Okay. Unfortunately, you can't leave this decimal in the fraction. So for my purposes, -3/2 divided by 2. If I keep, change, and flip, I'm going to see that I get a -3/4. So -3/4. Okay, if you did it on your calculator, you would have realized that you got a -3/4 as well. Okay, average rate of change from x equals, where x is -2 to -1. These are just different interval notations here. So -2 is all the way up here at that 8, and -1 is here. Oh, this one's a little bit nicer because these are nice, pretty whole numbers for us. So we're going to count the slope. Down 4 over 1, so down 4 over 1 is just a -4. Notice that these two average rates of change are not the same. That's because this piece of the graph right here has a different slope than this piece of the graph here. This slope is steeper and this slope is less steep. Okay, so that means this number here should be bigger because that was the steeper slope than this number down here, which was less steep. So you should notice that with exponential functions, your slopes between two different points are going to be changing all the time. Okay, the next one down at the bottom, example number 4. Okay, we're going to talk about this one is again an exponential. You can look at the function or you can look at the graph to tell that. If you don't know how to do that, you need to go back and watch the videos from the previous lessons. Okay, the day 1 lesson is where we identified those. Our asymptote again here on this one is going to be where this is getting closer and closer to. Now it might look like it's going to touch it, but that's just because that's the only way we can graph it. Okay, but it's just going to keep getting closer and closer to this asymptote, which is what's being added or subtracted here at the end, which is 0. So this is y equals 0. The domain of this is -∞ to +∞. The range of this is going to approach the asymptote, okay, on the small end, and then as y's get bigger, they're going up towards infinity. Okay. Our end behavior, remember this is going to the right, so as we look to the right side of the graph here, we'll notice that these y values are just getting bigger and bigger, so +∞. As we look to the left side of this graph, these values are getting smaller and smaller, but they're not going to get infinitely smaller. They're going to get smaller and smaller, closer and closer to 0. They won't ever reach 0, they will never pass 0, so closer and closer to 0. Okay, here we're going to go from the average rate of change from 1. So when x is 1, here that's going to be 1/2. And when x is 3, that's up here at 2. So this is going to go up 1 and 1/2 and over 2. So up 1 1/2. Okay, again, that's 3/2 over 2. I'm going to do keep, change, flip on these. Okay, this is going to be a 3/4. Okay, if you are doing that, you can use your calculator to help you find that. Okay, the average rate of change from x is 2. These should have or equal to lines underneath those, sorry. And then when x is 0, so x is -2, this is really small. And when x is 0, that's really small. So on these ones, you would want to actually plug these into the calculator. So 1/4 times 2, we're raising that to the -2 power. This is going to give us a 1/8. Okay, I'm just doing the math for you on here. Okay, at 0, this is going to give us a 1/4. Okay, when we plug this in, we get 1/4. Okay, so we're going from a 1/8 and we're going to rise. This is very kind of hard to see because it's so small. It might be easier to do y2 minus y1 over x2 minus x1, so let's try that. These are my x's. My y's that go with this, we said this y was 1/8, so that's y2. This one is going to give us, we said 1/4, which is that's y1, and this is y2. Okay, so I'm going to jump right up here so I have somewhere to work. So y2 minus y1 over x2 minus x1 minus negative on the bottom is going to turn positive. Okay, 1/4 minus 1/8. I'm going to make this have an 8 denominator, so this is 2/8. So that means we have a 1/8. Then we have 2/8 minus 1/8 is 1/8. 1/8. Change the division to multiplication. Take this 2, flip it, and we actually get 1/16. So this is 1 over 16. Notice again, those are not going to be the same. Okay, so similarities between linear and exponential. Okay, with linear, your end behaviors were approaching infinity or negative infinity, but for exponentials, they're not always doing that. Well, one of them will, but the other is going to approach an asymptote. Okay, and then average rate of change is still just counting the rise over run. Okay, now we're going to look at the last type of function that we have. This is our quadratics. So you look at those, we can see that these are quadratics. They are parabolas. This is a quadratic. Okay, I'm just going to go ahead and write my domain, negative infinity, positive infinity. My range on this one is a 1 to infinity, just doing that to move through this problem a little faster. Our vertex is either the highest or lowest. So on this, because it's opening up, that means we're going to have a min, which means that is where my vertex is. So my vertex is an ordered pair. This ordered pair is -2, 1. Remember, your axis of symmetry always should be going right through your vertex. It should be cutting the parabola in half. So what x value is this going through? It is going through -2. So x equals -2. It's a vertical line that's not really there. Okay, so as x goes to the right, so as it approaches infinity, so as we look to the right, these values are just going to get bigger and bigger. And as we look to the left, these values are also getting bigger and bigger. Remember from when we did this in class, these are both going to be the same. For quadratic functions, either both of these should be approaching positive infinity or both of them should be approaching negative infinity. Okay, when we talk about the average rate of change here, again, let's go from -1 to 1. So when x is -1, we're here. When x is 1, we're up here. So let's count the slope. So rising 1, 2, 3, 4, 5, 6, 7, 8. And we're running 2. So rise 8, run 2. This is going to give us a 4. Okay, and we're going to look on the interval from -4 to -2. Well, -4 is right here. Negative 2 is right here, so we're actually going down 4 and over 2. So down 4 over 2, which gives us a negative 2. Notice those are not the same because the slope between any 2 points on a quadratic is varying. It is not constant, so we will not be getting the same number every single time. Okay, this one is another quadratic. You can see that it's our upside down U this time, so we have another quadratic. Okay, our vertex on this one is a maximum, and it's at the ordered pair 3, 8. The axis of symmetry cuts right through the middle. It's going through the x value of 3. Remember, that should be the x of our vertex, if we remember when we did this in class. Okay, the domain of this is going to be negative infinity to positive infinity. The range of this one is a little different. It's negative infinity, so the lowest it goes is down forever, and the highest this one goes is 8. Remember, it's a point, so it gets a bracket. Our end behavior, so as we look to the right of this function, it's going down, down, down. So these values are getting smaller and smaller, negative infinity. As we look to the left, okay, so look on the left side of this graph, these are also going down forever towards negative infinity. Again, they should be the same. All right, our average rate of change, we're going to go from 1 to 2. So when x is 1, here's our point. When x is 2, here's our point. So let's count our slope. 1, 2, 3, 4, 5, 6. So rise 6, run 1, which just gives us 6. This one, again, these should have or equal to symbols on them. Sorry about that. So we're going to go from 3 to 5. So here is 3. Here is 5. This time we have to go left to right, so we've got to go down. 1, 2, 3, 4, 5, 6, 7, 8. And over 2. So down 8 over 2, which gives us a negative 4. Again, those are not the same. Okay, and then to wrap it up, any similarities or differences, okay, you'll notice that exponential functions and quadratic functions, their average rate of change is varying, but linear functions always have a constant rate of change. Okay, our end behaviors for quadratics are always going to be the same. Either they're both going up or they're both going down. Our exponentials and linears are not always that same. Linears are going to have one going up, one going down. Exponentials are going to have one going towards the asymptote and the other is going to be going towards an infinity. Okay? If you've got any questions, please make sure you reach out to me. Bye.